Hey guys, welcome back to our channel Get Play Soon. In this video, we are going to see how insertion sort works and how to implement insertion sort in Java. Let us see how this unsorted array in the slide is sorted in ascending order using insertion sort. Insertion sort works in a manner similar to sorting a deck of cards by repeatedly inserting each card into its appropriate position among the cards already sorted. So, the algorithm then iterates through the unsorted part, taking one element at a time and inserts it into its correct position in the sorted part by shifting the larger elements to the right. The process continues until all elements in the sorted part are processed and the entire list becomes sorted. Now, let's understand this example step by step. By default, let's consider the first element as the sorted part of the array. Compare the second element 52 with the last element in the sorted part 38. Since 52 is greater than 38, no need to change their positions. Next element, that is 9. Take the third element 9 and compare the elements in the sorted part, the orange colored ones. Now you can see 9 is inserted as the first element as 9 is less than 38. 9 is in the sorted part of the array. As the arrow is pointing, take the fourth element 18 and compare it and insert it into its correct position in the sorted part. You can see 18 is placed between 9 and 38. Take the fifth element 6 and compare it and insert it into its correct position in the sorted part. As 6 is less than 9, 6 is the smallest element. 6 is inserted in the first position. Take the last element 47 and insert it into its correct position in the sorted part. This is how insertion sort works. Now let us see how to code insertion sort in Java. Let's start with the main function. We have created an integer array with these elements 38, 52, 9, 18, 6, 47. Then we are passing the array to the insertion sort function. Once we get result from the insertion sort function, we will run a loop and print the sorted function. Now let's understand the insertion sort function. For looping purpose, we initialized integer n with length of the array. Moving ahead, we have a nested loop, a for loop followed by a while loop. The outer loop, that is the for loop, iterates from I is equal to 1 to I is equal to n minus 1. The I represents the index of the current element in the unsorted part of the array. It starts from the second element, index 1, because the first element index 0 is initially considered as the sorted part of the array. Inside for loop, variable key holds the value of the element at the current index I. In the next line, j is initialized to I minus 1. This sets j to the index just before the current element. The while loop verifies two conditions. J is greater than or equal to 0 and array of j greater than key. What are these conditions? The loop will execute as long as the element at index j in the sorted part and is larger than the key. So, if this condition is true, it goes inside the while loop. The loop shifts elements to the right. Array of j plus 1 is equal to array of j. This prepares an open slot for the current element in its appropriate position. The while loop then searches backwards in the sorted position j minus minus until the correct spot for the key is determined. And finally, after the while loop, the key is inserted into that slot. Array of j plus 1 is equal to key. This is how we implement insertion sort in Java. I hope you understood this. In case if you have any doubts, feel free to comment below. Time complexity of insertion sort. The time complexity of insertion sort is O of n square in the worst and average cases, where n is the number of elements in the array. This is because in the worst case, for each element in the unsorted part, the algorithm may need to compare and shift every element in the sorted part before finding its correct position. Space complexity of insertion sort. The space complexity of insertion sort is O of 1, which means it uses a constant amount of extra space regardless of the input size. The sorting is done in place, meaning it doesn't require additional memory proportional to the input size. That is it from my side. Thank you. Bye bye.